Okay, welcome to linear algebra. This is the first video in our series of videos for our class, and the first major topic is systems of linear equations. And so let's start with an example. So read this for a second. Three objects, one with a mass of 2 kilograms, that is the one right here. And then we have two other objects of unknown mass, and those are labeled H and C. And we would like to be able to use this balance apparatus to figure out what the two unknown values are. And the main idea here is this idea of a moment of a mass, which honestly, another word that I would probably have used from my basic physics knowledge is torque. You know, if you've got some like this mass, like this 2 kilogram mass here, but it's 50 units, let's say 50 centimeters away from the balance point, then it's really the farther away it is, the more it's sort of pushing down, right, on the side of the balance. And so the actual way to measure that is just mass times distance. So that's what's right here, mass times distance. And so, for example, for this mass, for this 2 right here, we would have the moment would be 50 centimeters times 2 kilograms, I guess. So that's some units I don't really care that much about. This is a math class, not a physics class. Okay, so it's 100. Okay, so the moment of that's 100. So now if we want to use these balances to find, to get some equations that hopefully will let us solve for H and C, we can sort of see this, right? Let me just scroll this up a little bit so I have some room to write. We have the first balance, the one on the left, so that we want the moments on the left to equal the moments on the right. So it's the sum of the moments. So on the left, we have this object H that's 40 units away. So that's 40H is the moment of that. And then C is 15 units. So that's 15C. And then that has to balance the moment on the right, which we just saw was 100, right? So that's one equation that we get. And then the second balance gives us, just very similarly, you might stop, pause the video, try to write it down yourself and see if you get the right thing. I'll pause for a moment. Okay, you'll get 25C on the left, right? And then on the right, you get 25 times 2 for that one that's 2 units. I mean, it's 2 kilogram mass is 25 centimeters away, plus 50H. Okay, so we have two equations, and if I just want to maybe simplify them a little bit, we have 40, well, I'm not simplifying this one, but let me just rewrite the second one as 25C equals 50 plus 50H. Okay, and that's a system of equations, right? This thing right here is called a system of linear equations. It's 2 equations and 2 variables. And it's linear because the variables, the functions are all linear. We each have linear expressions in the variables. We don't have H squared or C squared or H times C or natural log of H or something like that, right? So we just really have linear combinations of variables. And that's called system of linear equations. Now, you could imagine how you might want to solve this. For example, it seems like an easy thing to do would be to isolate, to just get the value of C if you divide both sides by 25 and then plug that in there. You know, you'd have it in terms of H, plug it in there, solve for H, get the value of H, plug back, get C. So you can do that. You may want to pause the video and try to do that yourself to just find the answer. But what I'm going to do is actually do something more systematic. I want to think about how to systematize. That's the whole point of this, is we're going to have these systems of equations and we want like an algorithm for solving them. So the first thing we want to do is sort of systematize or write it down, rewrite, maybe I have to say it this way. We want to rewrite the system in a standardized form. What's the word? Form. Okay, so what do I mean by that? Well, I'm actually going to put the variables, I'm going to line up the variables on one side and the constants on the other. So for example, if I'm just going to rewrite this. So let's just say the first equation, maybe I want to put C first and H second, and then have the constant after the equal sign. And so if I want to do something similar with the second equation, we'd have 25C on the left, and then I can subtract the 50H over from the right, and then leave the 50, the constant value 50 on the right. And so, you know, what we've sort of done is we've lined up the C's, we've lined up the H's, and we've lined up the constant terms. And that could be considered more like a systematic way to write down the system of equations. So let me just put that in parentheses. That's kind of our system. And now if you want to think about also a systematic way to solve this, you know, if the numbers were worse, it might not feel as good to isolate C and plug in for H. So, well, what kind of the real idea is what kind of operations can we do? And so one thing that might jump out of you is you can sort of simplify both of these by dividing by, there's a common factor, right? You could divide by 5 there, and you could even divide by 25 here. So let's do that. That's not going to change the equations, right? You can do the same thing to both sides. You can multiply or divide the same, both sides of an equation by the same number. So if we do that here, let's see, I think we'll get 3C plus 8H. You can always pause and get ahead of me. Let's see if you get the same thing I get. And then we divide by 25, which that doesn't really look like 25. Let me try to rewrite that. To get some better handwriting on this iPad. It still kind of looks like 25. Okay, and then if we divide through by 25, we get C minus 2H equals 2, right? Okay, so that's the first thing we've done. And now the next thing to do, and this might be something you've sort of thought about before, is we can combine the two equations to get rid of one of the variables, right? Like if we sort of, if I want to think about it this way, if we one way to think about this is if we sort of, oh my God, if we multiply this times 3, if this whole equation times 3, then we'd get a 3C right here. And then if we subtracted the two equations, we'd get rid of the C's, right? And then we'd have the H's left over. So that's sort of a nice step. But I want to do this slightly differently again, because it's going to be sort of systematic. What's going to turn out is, especially if we have a lot more equations, is it's going to be nice to have that there's a 1 right here, right? This is really there's really like a 1 in front of this C. And so it's going to be nice to have that as the top left, because then you can clear out the other variables. So the thing I'm going to actually do is I'm going to switch the order. You can think, it doesn't really matter what order you have the equations in, right? So I'm gonna switch the order and put C minus 2H equals 2 first, and then 3C plus 8H equals 20 second. And so that's what we did there to move down to this next line. And then, okay, then this takes, another way to say what I was saying before about sort of multiplying one equation subtracted from the other. We can actually multiply the first equation by 3 and subtract it from the second equation, right? So subtract 3 times the first equation from the second equation. But I actually want to keep the first equation because I don't want to lose information. We're going to still need the information from the first equation. And if we're going to make this sort of systematic, this is a way that it's done. If we do that, let's see what happens, right? So right here with the 3C, if we subtract 3 times the first equation, that's a 3C. So that actually gives us like a 0C. Maybe I'll even just write it. I'll just write 0C there. And then we take 8H and we subtract 3 times negative 2H. So that's actually adding 6, right? 8 minus 3 times negative 2 is plus 6. So that's 14. Again, you should pause frequently and get ahead of me. See if you can do the same thing. And then we do 20 on the right side of the equation. We do 20 minus 3 times 2. That's 20 minus 6. That's also 14, which is convenient. And so we get 14H equals 14 there, which is nice. And in fact, you can then, again, I'm just going to belabor the sort of like things here because the whole point is to make an algorithm for this. We still have the first equation, c minus 2h. If we divide the second equation by 14, we get h equals 1. That's exciting. And at that point, we can really just plug it back in, right? And get rid of, and solve for c. So h equals 1 is our first answer. And then if we plug in, we'll even talk about how to even keep doing steps like this to get rid of the h in the first equation and just be left with c equals and h equals. But you know, there's sort of like a back substitute plug-in thing we can do here, and then we get c minus 2 times 1 equals 2, which I think means that c equals 4. Okay, so we found that h equals 1 and c equals 4. So we know the masses of those two objects. All right, there's lots of different ways to do it. This was just to give us sort of a sense of how we're going to go about this systematically, and I'll show more examples, and I'll talk about the general structure of this in future videos. Okay, I'll stop there.